It's really needed because there's already a lot of girls in technology and 3D printing and all of that stuff, but we're not nearly there in regards to hitting the 50-50%, because a lot of technology companies, of course, have their 2030 plans of having 50% women and 50% male in the technology world, and that's not happening yet. So initiatives like this with Elegoo is just really important. So the first thing that I want to sort of teach you is how to start this, because a lot of people kind of see really cool designs and they see all of that, but how do you start it? So one of the things is that you want to start from the technology side if you're not there yet, sort of. So pick a proto board or a computer board. There's many things that you can start with. You can start with a Raspberry Pi if you're already known to Python programming, for example. You can, what I'm here teaching is a little bit more the basic. I would start with an Arduino, not because I work for them or something, but it's just a really easy way to get into sort of electronics, sort of. So this is, for example, an Arduino. It's an open source electronics platform. It has really easy to use hardware and software. It has its own programming language based on wiring, and it also has the Arduino software, so the IDE, which is based on processing. So you can basically tell this board what to do. So you can basically code it by sending a set of instructions to this board, to the microcontroller of the board, and it can do whatever you want. So this is a proto board, so it's about this big. That is not something that in the end you might want to introduce and integrate in your garment, but this is solely to prove out your electronic setup and all of that stuff, because otherwise it's a pretty big board that you might put in there. For a prototype is totally fine. I'm going to explain you a little bit later on how to also minimize that, or even how to make your own board, of course. But this is the Arduino. So you see the Arduino here, it has a lot of details that I'm going to go over later on. So I'm going to do this in the second hour. The second thing is setting up the environment. If you are downloading the IDE, which you can see on the website, is all free. So the controller, you do need to pay for it, I think $20 or something like that. The environment, it's free. You can download it. It's open source. So you can see, if you go to arduino.cc, I'm going to explain you in the second hour. You can see how you download this. The next step is getting a test setup, so hardware. So whatever you have, sort of, whatever you want to make a robot, or you want to just make something light up, or what I mentioned, you want to sense the heartbeat. Those are the physical components that you need to source. I'm going to tell you also in the second hour how to do that. You need to learn to code a little bit. There are already a lot of examples. I'm going to show you later as well in the second hour how to code. But in the end, you will need to code your project in order to send the instructions to the microcontroller of the board. And then the step 3, or in this case 4, what I would say always is integrate and minimize. So this is what I mentioned before. You have a big Arduino. From once things are proven out, you can directly solder to the pins, or you can put it in a breadboard, which I'm also going to explain you. And then you can make things with a really small board. And this is basically the second hour that I want to go into this a little bit deeper. The first hour, I want to show you a little bit more on integration and design. So how do you approach that? How do you put basically, I'm just taking something, a piece of electronics into your design, sort of. And I want to show that to you by going through some of my work and explaining you how I did things and what basically the request was from the client and how I integrated things in the end. And this is a little bit part of my normal lecture as well. But in this case, I'm going to dive deeper into the technology and the use and the applications of that. So I do a lot of work on the body, and I am sensing the bodies as well, the body as also the surroundings. The first part is a little bit more about sensing the surroundings. So we all have these spaces around us, the intimate, the personal, the social, and the public space. These spaces all have measurements. What I always name is Edward T. Hall. He's an American anthropologist in the 60s. He started to notice that different people have different personal spaces and different spaces around them. He called this the proxemics theory, and he wrote about this in his book, The Hidden Dimension. So this circle of spaces. So when I'm doing body sensing, when I'm using any kind of proximity sensors or heat sensors or ultrasonic rangefinders or ultrasound, which is the way that bats communicate, for example, you can think that you can use these spaces sort of, and you can program these distances as well. In the case of Edward T. Hall, he didn't have these sensors. It was the 60s sort of, So he used a wooden stick basically like this, to measure people's personal spaces. So it was a very analog way of measuring that. We have now sort of digital means. We have digital sensors that we can do this with, sort of, and that makes it much more fun to measure spaces like this. So I took his research and I programmed that into my systems. This is, for example, where you can see that there's two versions of the spider dress. One was laser cut. I'm going to show you in the end. This one was with Intel and Philip Wilk. With Intel, I was working there in Portland at RS5, and we had a new controller. It was the Intel Edison out, and Intel was asking me, hey, do you want to make something with this? And I already had the spider dress project prior, but I wanted to make it more smart, sort of. So I wanted to use their controller to put that in my design, to both beta test their piece of hardware as also build something, because I built things in order to prove how to make a report or to do any kind of beta testing on how their, in this case, controller was working. So I proposed to remake this dress, but do it 3D printed. So this dress was printed in PA12 in selective laser sintering. And down here, you can see two sensors. Those are ultrasonic rangefinders from Maxbotics, and they measure up to 25 feet, which is 8 meters. And when people come into the personal space, my system is seeing that. So my interaction here is data coming in and an effect happening. So basically with technology and with electronics, we work with, or in this case, I work with a sort of system in where you have the microcontroller, so it's the board, you have the input, and you have the outputs. In this case, the input, you can already guess, is proximity, right? So it's the person walking into the space. The microcontroller and the computer board is processing this all and is pushing out the interaction that is wanted. So that is the interaction. So one of my backgrounds is interaction design, in where you look at the system, sort of. And this is an input and an output situation. And in this case, not the Arduino is doing the interaction, but it is the Intel Edison, which is their microcontroller board that they were promoting at that time. So if you're designing a project, think of your input. What is your input and what is your output? What is the effect and what is the trigger, sort of, and then you can say, I'm using a Raspberry Pi or an Arduino or an Intel Edison, or I'm making my own board using Eagle, for example, which I'm also going to show you later, or any other PCB design tools. So when you're designing, that's really important to think of the interaction, what does it do and at what moment? And then you can think of starting to implement this when you're, for example, coding. So in this case, the sensors are there. And when you're stepping into the space, the design is reacting and it's literally attacking you, sort of. And that is based on that interaction that I designed, and that is also programmed into this dress. It works on something called 12 states of behavior. So depending on how you walk into this design, it's reacting differently. So it chooses between those states. So when you walk up very quick, it sees your speed and where you are, because it measures in beams, sort of, So when you step into this space, it can see that and it reacts accordingly. So when you walk up very quickly, it will also react very aggressively back, sort of. When you're talking about electronics on the body, sometimes you want to show the effect or you want to show the effect without having all the wires there, just for purely the effect. So it's very magical, sort of. At other times, and this is, for example, I'm not showing it here, but there's a project called Proximity 2.0, which I created for Studio Roosgaarden. Which is in a studio here in the Netherlands. It is a PDLC foil with switches in transparency. So in that case, you only want to show the foil and not all the wires, because you might want to make it look less geeky. And in this case, I really want to make it very geeky. I wanted to show all the wires, where everything goes and all of that stuff, to make it really this sort of exoskeleton style. So what you can see here, because I stopped the movie for a second to show this, is the back piece. So all my electronics are currently stored in the back piece on the back. So then you can think of what I already told you, the controller board, your computer board, so which is in this case the Intel Edison, your battery, and also all the wires going in there. are basically all the servos. They are Hobby King servos, 939 MG servos, they're called. They're connected to Pololu servo controllers, which are under the shoulder plates of the dress. And they're connected and going into the system. And the system is doing all the validation, all the calibration, and also all the interactions. It's being fed by a battery, which is also in there. And everything is connected. So definitely I wanted to show everything that was happening on the body here, because if you're either way showing wires, show it all sort of and make it also part of your design. That also goes with part of interaction design, and the design also goes about using sound and all of that stuff. These servo motors make by nature already a sound. When they go off their metal gear and they go off and they make a little mechanic sounds. When you're working with robotics and servo motors or DC motors or whatever motors you're using, there will be certain sounds. So when you're thinking of interaction design, you also want to take the sound in consideration. And in this case, when they go off, they also make this very eerie sound because of all the mechanics. If you want to make a soft robotics project that is making maybe no sound, or you do not want the sound of servo motors or something, you cannot use that. Really think of that for the interaction. Make them move slower is one idea. You can also think of using soft robotics. Soft robotics is anything to do with silicon. It might have some little pumps or the way you activate and actuate these soft robotics and all. But the sound of electronics is definitely something that you also want to take in consideration when you're designing things, because if it needs to be a silent project, you definitely need to make a few prototypes in order to make sure that any mechanical component that you have doesn't interfere with that. The second project that I'm presenting here is the smoke dress, which is created. Was the first time that we could work with PA. So this is a PA12. Which is polyamide. It's printed over selective laser sintering. So it's the powder printing process that I named already before, that I started with in 2005. This is the full capacity at that time of the thing that we could print. This was with Materialize in Belgium, and it was the first time that we could print really big things out of selective laser sintering and these materials. In fact, whole cars at that point were being prototyped. That was the first time that we could do that. So that was really cool. So I decided to create a dress with a collaborator of mine. His name is Niccolò Cassas. He's an Italian architect. And it was the first time, that was in 2009, I think, that we started this project. So 3 years in of me learning to 3D model, 3D print, and working with all of this. We decided to print a full dress. This is the smoke dress. It works with the same amount of sensors, ultrasonic rangefinders, but instead of measuring a one-to-one interaction, it measures the amount of people that are in the direct environment around this dress, and it starts to smoke. So basically what you have in the interaction, what you're seeing is that the more people in the direct environment of this dress, the more it starts to smoke. So it indicates more people, more smoke, sort of. In this case, it's the same setup as the spider dress. So the input is again an ultrasonic rangefinder measuring not a one-to-one situation of one person stepping in, but a crowd. So the more people, that is basically what is measuring. So it uses the same piece of hardware, but it uses a different kind of sensing direction. And the output here is smoke. So instead of mechanic movements and the 12 states of behavior that I programmed using the servo motors, in this case, the output is smoke. So here you can see the smoke system in the back, which is offered by this plate, how do you say that, by the back piece around it. And the system is 500 grams is in the back. It's based on another animal. I use biomimicry a lot, so learning from nature, looking at the behaviors of animals, which is a little bit inspirational for me and all of that stuff. So it's the inkfish. It pushes out ink so it can escape. And here you can see the smoke dress in the booth. This was for the client, was Volkswagen. Another kind of interaction using the same kind of hardware. When you're printing this, you mostly do that on a mannequin or on a doll. If you guys are designing anything for the body, I do have scans of models in any kind of position. If you want that, I can send them to you. I can share them with you. But use anything like a mannequin to directly maybe model on the body with, because that's always the best way, instead of doing it just out in the physical space, sort of. You want to do that on a body, and also a body that is closest to the body that you're designing for. So often when I have a design for somebody, I nowadays send them to a 3D scanning booth to basically have their body being scanned in, so you can directly model on that specific body sort of. Here you can see parts of the dress, part of the hip part where the smoke comes in and is being pushed out. And those were pretty important parts in this dress to evolve sort of. Here you can see the selective laser sintering process and also the TPU that's being used for the frontal part. So you can of course also 3D print in flexible materials. This was less known when I created this dress, was 15 years ago, when we were busy with it sort of. Then in that time there was not so much flexible solutions that we had, but the process of selective laser sintering is a CO2 laser beam goes in a scanner or a little mirror, goes down into the project build room, the process chamber. There's a swiper that goes up and left and right that swipes in another layer in this process chamber. While it's being sintered, while it's being materialized sort of. The cool thing about selective laser sintering is that you can do really complicated shapes there sort of. The cool thing about TPU, so TPU is thermoplastic polyurethane, or a TPE is a thermoplastic polyelastomer. So that can also be used with the Elegoo machine. So TPU and TPE is something that can be used as a filament. So if you're working with something, especially around the body, definitely think or consider using a TPE or TPU, because it can really bend around the body really nicely. And if you want to embed electronics in there, you can pop them in. So if you're using a harder material, then you need to make it really thin in order to pop it in sort of. So if you're doing anything around the body, I would highly recommend to use a TPU or a TPE, or really work on a body and really work around these body shapes, and also the movements, because if you're making a sort of an armor piece here, which I can show a little bit later. If you're making any kind of armor piece, that can look cool when it's just solid, but when you start to move, what does the body do? And especially, for example, your collarbones, there's a lot of movement that you need to reconsider making more flexible pieces, for example, right? Because otherwise your body cannot necessarily really move in that. So this is the smoke dress in my studio, so you can see the smoke coming through it, and also the system. And this is another of my designs, which is a cocktail dress, but a real one, because it really makes you a cocktail. So in here, it's not the full dress being printed. I'm only using solution of the 3D printing in the front piece, so you can see the heart, and on the back, which is like the back piece. But it's a little system. It works pretty simple in this case with a push of the button. It makes a peristaltic pump move. The peristaltic pump is moving the fluids to the front and is dispersing it in the little shot glass in the front. And the wearer is giving you the cocktail. So the input is a button, which goes to the controller. This is Arduino based. Then it goes to the peristaltic pump. So the Arduino makes the peristaltic pump move. And that creates the shot glass. So the input is the button. The output is basically the movement of the peristaltic pump. So it's just a rotational movement there. Oh, and that's the smoke dress. I'm not gonna show that now, but that should have been a little bit closer. And one moment. It's okay. I think we're good. Sorry, somebody came in here. So this is the cocktail dress, and the interaction of the cocktail dress as well. So the push of the button makes the peristaltic pump move, and that disperses the liquid, and then the liquid goes to the front and is being dispersed in this cocktail shot glass, basically. Here you can see the peristaltic pump within the back piece on the back, so how it's integrated. Here you can see that design walk around. In this case, it is for Cirque du Soleil. So Cirque du Soleil has a restaurant in Ibiza called Heart Ibiza, and they were asking me to create a design for them, and to create something that could walk around and also disperse any kind of food or beverage. So my research is always when I combine technology on the body, what does it do, and how can it create some kind of interaction? So other than just blinking and bleeping, how can it create something more than that? And that is part of the things that I'm doing. So my background is fashion design. Then I rolled into interaction design, into machine learning and robotics. So that is basically how I got to do what I'm doing now. Next to that, I also hang out a lot at makerspaces, or the former makerspaces, which were the hacker spaces, for example, in order to learn a lot about this, because in the beginning of 2000 there was not that much interdisciplinary research going on. So how can things become more social and playful, like the cocktail dress, or defensive and behavioral, like the spider dress, or more expressive and sensitive, like the smoke dress that I showed you? So really seeing fashion as an interface. So a social interface, a playful interface, and also an emotional interface. Talking about interdisciplinary is, it's still a little bit hard, for example, for the field that I'm in. So we're trying to make a lot of curriculum, or I'm trying to get a lot of more females and girls into electronics, for example, but I'm also an educator. So currently I have 140 students all over the world. So I am teaching at the Fonti School of Engineering in Eindhoven. I'm teaching at Summa College, the fashion school in Eindhoven. I'm doing projects with the Amsterdam Fashion Institute here in Amsterdam, with FIT, so the Fashion Institute of Technology in New York, with the New York University of Technology, and also with Design Morphine, which is a 9-month master program that you can learn, basically master computational design with. So in all that stuff, I'm trying to basically either educate fashion designers to think more technical, to use more technical means, or to work with engineers to teach them more design, for example. But yeah, one thing is to create more interdisciplinary research, which is really, really... So one of the things that I did at True is an exhibition that was called Technosensual. I was the curator and the creator. There was an artist in residency program with that, which was about a year. So I got the opportunity to get a lot of artists and designers to Vienna. This was at Museumsquartier in Vienna. And together with them, we were creating projects around fashion and technology. So everything needed to be basically based on the body. So after a year, all these designs were being basically showcased at this exhibition. And I'm going to show you some of that. And that was in 2012. So we had Bart Hess, we had this dress, you should brush it. It started to move. Pseudomorphs, it bleeds ink. So this one is a little brush, that was the input, and it started to move based on that. Yeah, so the exhibition was called Technosensual, where fashion meets technology, and it was all about like the interaction of these pieces and searching these interactions between the body and fashion. So this was used by Melissa Coleman, was a lie detector. You put your hands on it, started to showcase lights. Maartje Dijkstra, she made a suit that you could DJ with, which you can see here. So there were a lot of pieces, I cannot all name them, but there were 30 pieces in that exhibition that all had to do around these kind of the senses and our bodies sort of, and also how to use these senses, or your senses touch, sounds, sights, seeing, all of that stuff. How could you use that in a different way? There was also like a symposium, next to it, and all of that stuff. This was the Dare Droids. That was one of my former cocktail dresses. You needed to play a game of truth or dare with the system, and then it gives you a drink or not a drink based on your answer. So that's another way of looking at these interactions. Yeah, it was a highly successful exhibition, and it was really all about searching these interactions, like what are the possibilities there, and so on. And again, interdisciplinary research is really important in there, and especially as I mentioned before, if you're starting with electronics, like really get a good base into what you can do with it, because the last thing that you want to do is kind of blow up your system or make like stupid mistakes in where you have your whole design ready and you're doing something like short circuiting, or there falls a little bit of water on it, or there are multiple ways that designs can get destroyed when they're embedded with electronics as well, of course. So getting in within interdisciplinary research, getting a stable base of electronics, for example, is just really, really collaborations that you can think of. I did a lot of collaborations. One of the collaborations that I did was with car band Audi. I worked with NASA, ESA. So You can think from space agencies to automotive, for example. I do a lot of work for the Volkswagen Group, which you saw already the smoke dress from, and also Audi in this case, sort of. You can think of applications in the medical field, so from Philips to all kinds of research. Talking a little bit more about brain-computer interfaces later on, and all of that stuff, sort of, you know. So the field of fashion tech is just really pretty and really deep, because more and more people are interested in the body and what you can do with it, and anything that you can place within or on the body, which makes it just a really fun thing to do, sort of. So one of the collaborations was with Audi, which I thought was pretty cool, because you always need to look at where is your identity as a designer, what is the request of the company, where is their kind of where are they at, sort of. This was where we were looking at ways that we could integrate the car design into the dresses, sort of. And you can see that here. So the LED matrix technologies of the cars was in there, the sensing technologies. So the parking sensors were taken out and put in these dresses. And that became a really fun project in where we needed to put a lot of technology, electronics, a lot of effects on the body, which you can see here. So this is one of the main dresses. And it uses really bright LEDs. A lot of bug pucks are in there, integrated in the back, sort of. And it really blasts out this light bomb, sort of, which was a really cool show effect. Another one, and I'm going to show you this first, was a projection map dress. So because we have the data already of the dress and the pieces on the dress, sort of, it was easily to correlate that into the digital world, and then do a projection mapping upon here, because it could recognize these shapes. And then we're using cameras during the live show, which you can see there, which are tracing the models and tracking them, and then projecting back onto the dress, which you can see here. So that was kind of a really fun thing to do as well. Within shows, you can do a lot more with environment as well. So you can have additional projectors in this case, that are projecting on the models, which you can maybe not do if you just have a model like walking around somewhere, because it needs to come from within the design. But this was the final showcase that we did with Audi for the Audi City Berlin. That was in 2015. Where you can see the design changes. I don't think that you hear the music, so I'm just going to. We were using it on the keyboard, which was kind of a new technology that were like these on to do shows in China and on other places and all of that stuff. So sometimes you are prototyping something that you are still with, but then you also need to give it away, because it goes on tour with a company, and you are already on another project. So in this case, it needed to be like really stable, reliable, and also working as easy with sort of the venue. So that can be over the light controllers. The Volkswagen show that you saw, we did everything through Zigbee, so XP protocol over DMX controller, so the light control system of the venue. So when you make it to travel beyond you being there, that's a whole other process. But that was really fun here, because it traveled to a lot of companies, or to a lot of with a company to a lot of countries, and then at one point it cut again, sort of, to us. Then another thing is which I haven't talked about, was prosthetics. So you can not only think of things that are happening on the body, but also like really literally being part of the body. So prosthetic and legs, which you can see here. So this is Victoria Modesta. She's a really cool sort of advocate for people that are differently abled. She lost her leg pretty young, pretty early in life. And she decided not to have a leg back that is from kind of looking like a normal leg. She really wanted to expose it to be like very bionicle, or like very out there, sort of, you know, in order to raise like awareness for people that have prosthetic arms or legs, to really make it an eye catcher, sort of, you know. So she has been working on a lot of art legs through her career. And I met her in 2015, and I told her that it would be really cool to put electronics in her leg and make effects happen, because I could use that space to fill up with electronics, really, really, sort of, you know. So that was my request to her, if we could do an exploration, sort of. So here you can see some of the fruitation of that. So you can see on the right side a leg that is basically like the smoke dress. She steps in it, it starts to smoke. This was a product for Art Miami in 2016 or 15. She has a leg that has an accelerometer. When she moves her leg, you can measure the place in space of of the accelerometer. You can see where it is and where what the leg is doing, and it starts to make music. She can sonify that music using bodies that she is wearing. So it was a kind of really fun collaborative piece in where she kicks in the sound with her leg, and then she sonifies that with a bus. The instruments on the back are from Eric Goldenberg. He makes 3D printed instruments, which is really cool. So his studio is called Studio Monad. So definitely check that out as well. And yeah, that was a really fun thing. Later on, I went on making pieces for her show, Crazy Horse Paris. It was an sort of burlesque entertainment show, which you can see here a little bit about. But it was a light up spike. And then the other one that you saw was a mechanic, leg with a mechanic element, which is pushing out lights, and it fragments light to all sides. So that's the one that you can see here on the right. To a project that we did in 2019 for Rolls-Royce. And I'm just gonna make this little notification go away. And yeah, this was the product in 2019 for Rolls-Royce, in where we used a really small Tesla coil, put it in the shoe. The shoes were a collaboration with United Nude, Rem Koolhaas. And basically there's a void space within the leg, and a Tesla coil is stirring an effect that's called a Jacob's ladder effect when the voltage is raising through that. Again, I don't think you can hear the sound because I have had a problem with my sounds for my. This was basically the sort of the movie that was made for this release of a new car. The car was called the Black Badge. Tori was asked to create a sort of a collaboration for that. That was inspired by this new car, by the Black Badge. In there you can see her more from moving human to. So yeah, how that looks when you are like prototyping it. So when you're working with technology, you make a mock-up. So something to prove out what you want to do. So you want to make a LED blink within your design. You might not put that already in your design. You might want to make a little test, sort of. So that's called a mock-up. So prior to the prototype, you're making a mock-up. So that's what I'm showing you here, sort of. And the mock-up is informing your dimensions, your size, what it's going to be doing. The effect, can we minimize it, can we scale it down, such things. So you have a lot of basically questions as an engineer when you are creating a certain certain setup. So you prove that out by making a mock-up, and that's called kind of a proof of concept. Can we do this? And in this case, we could do that. So then you go into the next step, which is making a prototype, prototyping it out. Then that answers questions around the design. So the mock-up is answering questions around the technical capabilities and proving out your concept. Like, does this work? Yes, this works. The is more answering questions about the integration to the design. Does this look good? Is this aesthetically pleasing? Does all the your electronics all run well and the way that you want it, sort of? Does it compromise your design? How can it not compromise your design and all of that stuff? So your prototype is for that. And then with the knowledge of the mock-up and with the knowledge of the prototype, you can do your final design, sort of. So on the left side, you can see here the mock-up, and then you can see the kind of the down, which is just in the heel, so more the technical prototype, and then you can see the final design in there as well. Basically, what you can see is the heel. There is basically the board is in there. There is a really big heat sink because the board got really warm, and the battery is in there as well. You can see the coil in the back. Goes to the void of the leg, sort of, in the prototype. And then the final design is where you can fill you can close it with like the sensor plug, and when you release the voltage, it goes like through there, sort of creating this Jacob's ladder effect. So that is a little bit how you go on about mocking up, prototyping, and then going into the final. Your final can be that things don't work out. You might want to have a different kind of electronics use or a different kind of setup. So you might want to go back to your mock-up, or all together and start something new, or you are okay with a mock-up, like, okay, technically it's there, but the design is not there, so you create another prototype of your design, and that becomes the final design. So that is basically how you utilize and use the mocking up versus also the prototyping and going into final design mode. When you have the final design, of course, you want to test it. If something goes wrong or is not how you want it, it might go back in that cycle again of the mock-up or the prototype cycle, sort of, in order for you to really create a design for your client that was desirable or that they want, sort of. Going on, and I already talked a little bit about it, stagewear is a whole different thing. I've been working a lot with around that. We did a project, this project, Black Eyed Peas, for Victoria Modesta, which I already showed you, also for Britney Spears and some other. And when you're working with stagewear, you don't only need to take the body, but and the direct things around the body in consideration. You also need to think of, you take in consideration the whole venue and also all the audience, sort of. So this is not a really good quality video, because it is more like 15 years ago. This was the Super Bowl halftime show in Dallas in Texas that I for the first time cut to America for, because I got invited by the stylist of Lady Gaga. Her name is Bea Akerlund, and she asked me to create something sexy for Fergie. She was the the leading woman of female of the band, the Black Eyed Peas. And Bea Akerlund asked me to create something sexy for Fergie, and I thought these American football players' shields were really sexy. So I wanted to do something with that, sort of, to make it like super badass. So what you can see is, you can see the shield with LEDs embedded in there, and Swarovski crystals that I'm actually using as heat sinks. So they're actually cooling down these LEDs. And then she has a skirt with Swarovski crystals, and she has boots that are optic fiber fabric, so Luminex, which I went to the factory for in Italy to redesign that with them. So that was a really fun project and process for that. And I'm going to show this first. And there's no sound. One of the problems with the Super Bowl was there was a lot of light. So it really needed to be really well visible. And that was one of my things. So you can see each of these glimmers, that's not reflection, that's actually LEDs. And what I was using at that time was, they are called Rebel LEDs, and they were one of the brightest LEDs. The bad thing about those LEDs, that specific type of LED, the Rebel LED, was that they got really, really hot. And it got really, super, super hot. So the whole shield was not only aesthetically in the end, it was also functioning as a really, really big heat, cooling down these LEDs. And because of the Swarovski crystals were in a grid, the wind also went through it to cool these LEDs down. So it was, it really all formed a function all together. So this whole design was engineered to be kind of both a really big showpiece as also a really big heatsink, which I thought was really cool in the end. So so those things you need to think about if you're scaling up things from just a design that is being seen by one person in a gallery space, a one-to-one interaction like the spider dress, to a really big stadium that needs to see these designs, sort of, and in this case, I think it was really, really well visible. It was really, really cool, especially at that time, because now there's much more beefier LEDs and all of that stuff. So going from the stage to like these productions to something that I already mentioned in the beginning. When you're sensing the body, you can sense the surroundings. You can do something with the surroundings, like the Audi project, like the spider dress project, like the smoke dress, for example. You can also do something with the body itself. So not that you have sensors that are sensing the surroundings, but sensors that are sensing the body. And of course, you can sense the body in multiple ways. You can think of EEG, so that is the use of brain signals. You can think of pulse, blood volume, the pulse muscle contraction, so EMG. You can think of ADA, of galvanic skin response, for example. So EMG is best measured here. EDA, galvanic skin response, is best measured in the palm of the hand, or anything sweaty. It's good for fight or flight. Respiration is measuring the lung volume, so so it's better measured here. Accelerometer, which I already mentioned in the leg of Victoria, for example, the place in space of the movements of your body, and also HRV, so the heart rate and the heart volume, for example, and temperature, oxygen. So all these things you can measure, and much more. This is just one of the things that I've been using, and also the blue ones are the environmental sensors. So if you're looking at the body, the ways that you can measure that is, of course, EEG wants to be measured on the head. There are different places that you can measure, but it's not always super ultimate. Ideally, you want to measure the closest to your the parts of the body that you want to be close to, sort of, you know. So if you're thinking of your muscles, like EMG can be measured here really well, same places on your legs. For what I already mentioned, EDA, so galvanic skin response, best measured, for example, in the palm of your hand, where any sweat glands are closed, that you can measure it. Respiration, around your chest, you can measure the lungs when you're breathing. You can see the lungs and the lung volume. You can measure that by the use of a sensor just around that. And then also accelerometers on any of your body parts that do the XYZ, of course. And then our HRV, so the heart rate or the heart volume, better from the kind of the heart region, or pulse, for example, you know. So that is something that you can think of when you are designing for the body, because currently a lot of the wearables, which are now called wearables, are tracking things from more convenient places because they are consumer electronics. So it might be the wristband that we already know, or it might be like certain places that are more coming from the consumer electronic side than from a custom side of designing, sort of. So one of the projects that you can see me using HRV, so heart rate variables, is the Heartbeat dress, which is a project with Swarovski. It measures, in this case, heartbeat, not actually from the heart region, but from a frontal position, because Swarovski is a jewelry company and they wanted to do something around the neck. So they wanted to do more of an jewelry piece in there. So you can see here the full dress, and I'm sorry that there's some background noise. Somebody's coming in at the moment. And you can see here the full piece, and you can see it as a full dress. This dress is modular. So there's a full dress with kind of the hip pieces and this whole centerpiece that is 3D printed. But you can also use it as a collier, and you can also use it as just the jewelry piece, just the neck piece around the neck. So I'm going to show you a little video here that is showing that. So it's basically shows the neck piece being integrated, and then later on it shows it also as like this jewelry piece. The twist on the front is designed with Swarovski, so with the design of Swarovski, and it is created to be responsive. So there's a little layer on top of it. We can measure it. So there's three sections. So one is on off, the other one is just light. When you push it in the center front, it goes on the heartbeat, which you can see here. So from that point on, it's measuring from a frontal position. The heartbeat, it shows it directly. So then that is something mopping up and the prototyping, something testing, like what your system is doing is correlating with maybe another setup that you're having. So I was showing that there is always a good way of measuring and testing all of that stuff. So the main thing around this dress was that a lot of clients of mine often come to me and they say like, hey, Anouk, we want to create a design with you that is working on your emotions. But if you're talking about the fashion world or maybe also the world and also consumer electronics, they often want to have like kind of happy projects. It's same as on social media, for example. You see more people place like happy stories. They post when they're happy. They might not really post or really say things when they're sad or when they're depressed, for example, you know. So we are there are nuances in emotions, and it's all a scale, sort of, you know, and all the emotions that we have are part of. So it doesn't matter that you are sometimes sad, you're also a lot happy, right? So that conversation, sort of, but because in mainstream media, positive emotions are more kind of celebrated. It is not really the right time for us yet, currently, to really show a full blooming piece that really works on your emotions, I found, so, sort of, you know. So that is kind of my critic around that, because yes, it looks very beautiful when you're happy. It's a happy dress. It shows happy things, flowers, colors, smells, whatever that can be. But what happens when you're sad, and what happens when you're depressed? Because if it doesn't display that, it doesn't show the broad sign of us being human, of the whole range of our emotions, sort of, you know. So yeah, the clients like to think of happy things rather than sad things, of course, right? That's our world. So yeah, kind of to prove this out, I created this dress, which is a really beautiful piece. But when you turn it on, and for example, when I'm on stage, I like to sometimes put it on and turn it on, and it makes you very aware, because you all try to be very cool on stage. But when you turn it on, you see that your heartbeat pulses like really, really wildly. So, you know, so people can really see that you're maybe really nervous when you're on stage. While we're trying to make a poker face, and we're not trying to show that, right? So it's both like a nice complementary piece, and it's also a little bit a projection and a critic on this notion of like in a world where our garments are working on our emotions, like how does that look like, right? That's kind of the research there. The other bigger part of the complications here was to make the electronics as small as possible, so they could form around around the yeah, that is one of the bigger things in this case, that we want to make it as small as possible, and also integrate all of this, and also doing frontal position measurements of HRV of the heartbeat from a frontal perspective, sort of. So there needed to be a lot of components, and a lot of sensors, sensing units, but also machine learning was applied in order to do noise reduction. So if you're doing sensing of data, you do a lot of noise reduction, because not all the data that you get in is our body. It's a lot of noise. It's a lot of like just like little things that are happening that the sensors are picking up on, that sort of, you know. So a lot of that stuff needed to be in this in that case. For me, it's just a really cool piece, because both the size and the scalability of this, sort of. You can read a little bit more about it online. This was an article of Make that was publishing it, sort of. But for me, for the scalability, this project was really important, but also about the research into emotions and into what happens when you wear your heartbeat on your sleeve. What does it do, sort of, you know? And another project that I was doing at Intel, that was at the same time that I was creating the spider dress, the Synapse dress. So it's this 3D printed dress that was using TPU and SLS, was again with Nicolas Cassas, which I also did the smoke dress with. And one of the funny things here was that we used Maya, and then we used the texture, because we wanted to create a texture over it. So Nicolo used ZBrush, and then overlaid the ZBrush on the Maya file, which made it extremely heavy. So it was kind of a really funny way of like combining these two pieces of software, which you can understand like 10, 15 or 20 years ago was much harder to do. But I'm surprised that a lot of the softwares still, the CAD software, the 3D modeling software, still don't really integrate together, sort of. So you still have the same problem that we have in this case, that the both softwares were not compatible. So from the design to the ZBrush, and then layering the texture over that, sort of. But I thought it was a really cool design. It was fully made of TPU. So me and Nicolo, we learned from the project, from the smoke dress. We only had the little frontal part, but now we could really utilize the whole design. We could build the whole design using the TPU. So that's the thermoplastic polyurethane. And so everything here is flexible. So that's really cool. So the little wings to the frontal piece, and also the headset. And I coded it. I sort of did with sort of a metallic in there, which partially absorbs when you're using the TPU, creating this really cute, sort of grayish look. So again, it was with the Intel Edison at that time, and it was the second project, where the spider dress was really external. The Synapse dress was really internal, so as a research object almost. So integrating LEDs in this design, and using also, the first time that I was using a BCI, so brain-computer interface. And you can see that, in that time there were not too many commercially available BCIs, so brain-computer interface. It was a little bit starting. It was more from the medical side that there were a lot, sort of, but not really commercially available ones that were good. So what I ended up doing was taking Neurosky, and I hacked it. And then, yeah, we created a kind of a module in where it all fitted back again, sort of in there. So we modeled it part to fit that all. You can find this on Autodesk Instructables. So on the Instructables website, you can see this, yeah, sort of both the teardown as also creating the customized EG headpiece. And that was the Mindwave from Neurosky. The problem for me at that time was it was doing frontal yeah, positioning. It was measuring it from one sensor and just a reference sensor on the earlobe. And yeah, for me, it was not really clear what I was now exactly sensing, because when you're moving your eyes, that's already giving so much dominant signal, you know, that you can almost barely, yeah, get any EEG data from the frontal part, because yeah, your forehead is just really, really sensitive. And I mentioned before, using machine learning, there's a lot of noise and noise reduction that you want to do. But yeah, for me, this was a little bit like questionable, but either way I used it. But later on, you can see me do a project with yeah, the sensors in the back, in where I'm researching something called the P3 wave, in which is more focused on the focus sort of. But it was a cute kind of yeah, thing to integrate it. But I definitely also needed to use other things in order to measure her focus level. But the idea was that she was walking around, and as she was walking around, a lot of stress is being put on you, sort of, you know. She was walking to the Intel Developer Conference, so a big conference room, so people were there to say hi to her, or like, hey, what's going on? Or she sees things happening around her, and I was tracking her, kind of her focus, and anything that would gather her attention, the light would go on more and go lower, sort of. That was the idea. But I want to do that fully using brain signals, but in the end, I also needed to use HRV and some other things, proximity sensors also, for people that are yeah, getting more close, sort of, you know. So yeah, so that's a project later on turned into a project called Agent Unicorn, in where I'm also researching the focus level there. So and yeah, one of the other BCI projects that I've been doing around brain-computer interfaces is the Synapse project uses, in case, one sensor, sort of. This project uses 1024 channels. So also 1024 yeah, sensors in a way. It's applied on the full head, sort of. Here you cannot see the full setup. You can see that later. But it's a dress in where you can see each individual brain signal basically firing and having a connection with something within the dress. So we, I was working back, and they were creating this pangolin grid, and we're using the dress basically to prove this out. Why this is created is kind of really interesting, because yeah, you can do a lot with, for example, stroke rehabilitation, or anything medical that you want to measure brain signals. The only thing is that you cannot have hair. So in another case that I'm gonna tell you later about, you can have active dry electrodes that you stick to the hair. You don't even need a saline, the gel or something. In this case, you needed to apply them to a bald skull and directly to there, in order to make direct connection to the skin, and also yeah, measure to that, sort of. So you can read a little bit more about this on the website of IEEE Spectrum. So it's written a little bit about that, about the yeah, the control and the demonstration of this this new BCI technique, sort of. But basically, yeah, the notion was that everything that was happening could be shown and showcased in this dress. How you can really see this in really simple, sort of, the dress had yeah, 3 states. So it had a blue state, a purple state, and a white state. So the white state was neutral. The blue state was like stressed, and the purple state meditative. So when you go, for example, from just being normal, being centered, to thinking of like a lot of things, or things get hectic, it would go into the blue state. If you would start to meditate, so we were meditating, for example, with one of the models, her name was Mac, during Ars Electronica, and once she meditates, everything starts to move slower, be less like jacky, and like moving around, and start to become also all purple, as more that state more, sort of, you know. It was kind of a really fun thing. So the other project that I told you about in regards to focus was Agent Unicorn. I created it for the EU Commission in 2015, so also 10 years ago. They asked me to create something as part of an artist in residency, and it could not be a dress, so that was the only thing. So I made a headset, and it was a headset for children with ADHD, because I already did the research of the focus yeah, a little bit prior to that, so with the Synapse dress. And then I'm trying to apply that to another thing in this case specifically, and that's called a case study. So a case study is where you have a research question and you're going to work it out by any means to get your answer, sort of. So that is what you can see here. So that is that became 18 Unicorn, which is a custom BCI. It has a little camera. It measures what is going around like the wearer, and anything and everything that has an effect on them, sort of it will show, and it will start to basically record anything that is happening in the direct environment around them. So this is the headset. So it's like an unicorn horn with a little camera in there. It's based on a Raspberry Pi. So the Raspberry Pi is there, and also the EEG, all the backends for the BCI, and the EEG sensing is also incorporated in there. So that is what you can see here. So when you're working on things, again, and I explained this before, it might look like a little bit like not wobbly, weird when you're like prototyping out. I slapped here a unit of the BCI on there, and then you start to integrate. You start to integrate it and test it. So that's basically how the final design came about. So everything is based in that little box, which you can see on the back. You can see the sensor sitting here, and you can see the camera in the front, measuring, basically at all time measuring the focus state. When the focus state goes up, it starts recording. And this was in this case to work with children, to see if and what to do, and also to show them how their brain works, sort of that anything and everything around them has an effect on them, sort of, And if you have ADHD, that is even more in regards to when you get stimulation, all of that stuff. And for me, it was really fun to work with they're really witty, they really want to know all about like how their brain works and all of that stuff. So that was really a kind of a fun project for me. So in this case, it became a product, and we brought it out with GTech. The cool thing about this project was, again, and I'm not showing this in the slides, it does research to the P300, which is based for focus. So it has a few points in the back, sort of, that correlates to certain points in where you want to measure focus. It does that over something called the ERP, the event-related potential. And that became really successful way of measuring things, that we actually brought this out as a device, sort of. So this is the Unicorn, so that's with GTech. And GTech is a really cool company that used to have like 40 or 60% of the world market on medical EEG technologies. And we want to create something that was a little bit more for people that want to work with a medical scale device, so medically proven to be correct, but also like more consumer electronic products. So, but one that really works, that really measures the right kind of things. And especially again, 10 years ago, there were a lot of things on the market in regards to BCIs that were not really medically proven, that were just like more maybe sensing other things, for example, the way you use your eyebrows and micro movements in your frontal part of your face. I cannot really tell the brand, sort of, but so this one really came from the medical stuff. And we do a lot of like hackathons. So they're in a lot of like medical situations in hospitals and all of that stuff. So they're really widely popular. And also the other thing that we're doing with that is the Brain.io designer hackathon. And that happens again now in April. And that's either way a fun thing for you guys also, if you're interested in anything that I'm now telling about. So the BCIs and all of that stuff. There's the BCI Neurotechnology Spring School 2025. It happens on April 28th until May 7th. So that's Vienna time or Amsterdam time. I'm currently in the Netherlands. So I'm not sure if you can follow it wherever you are, but they also make recordings. The good thing is, if you're still a student, you also get points from it. But there's a lot of companies, like, so last time we had 82,881 participants from 118 countries. And then also, we had also the Brain.io hackathon also with the headsets. So if you want to learn anything about neuroscience, about working with BCIs, working with brain signals, it's free to attend, so you only need to register. So look this up, the BCI Neurotechnology Spring School of 2025. It happens at the end of this month, so April 28th until May 7th. And you just learn a lot from people from from the field, from doctors, from neuroscientists, from makers, from artists, from architects. So just all kinds of people are busy with looking at what's next for neuroscience, because I always say we think we know a lot about the brain, but we actually don't. We might know 5% or 10%, and there's actually little parts of the brain that up to like 5 years ago were still cut out of our brains. Well, that's actually a really bad idea, sort of, So we definitely don't know all much about the human body yet. So this is really, really cool that, for example, GTech is bringing all these people together in order to kind of show all their research and show also the cool things that you can do using BCI technologies, for example. So definitely join this. It's at the end of the month. Register, or what I just do is I'm also speaking. I'm also a part of it. So I also give some lectures about the use of BCIs, for example, in this field. So I'm also part of it, but mostly I just have it on and just do my work and listen to it. And some of the stuff is really, really high level. Stuff is more like easy to follow and all of that stuff. But it's really, if you want to get into this field, if you want to work with neuroscience or BCIs, is definitely the way to go, sort of. So the last projects around brain signals, also the last dress that I'm just, the last project that I'm gonna talk about is the screen dress. It was designed in Onshape. Onshape is from PTC, which is also creating SolidWorks. It's kind of an answer on ways that you want to maybe get into kind of a professional work remodeling program, but you don't have, you go hardcore with the use of like some other CAD softwares. Onshape is a really good way. There's a lot of tutorials if you want to get into like product design. That is, for example, a really good way to do that using Onshape. It's free. So you can download it. There's it's partially depending on your how you use it, of course. But if you want to get into modeling software, you can use Onshape. You can use something like Blender, for example. Whether yet a little bit more for the movie industry still yet. There's a lot of like parametric kind of interesting things that are coming about now. There's definitely more experimentation for the last 5 to 6 years with Blender. But if you want to get into how do you say that, product design, sort of, you might want to start with Onshape. There's other design software, of course. You can think of like Fusion 360. A lot of the projects here that you've seen are done in like Maya, in Rhinoceros. Using Grasshopper, Rhinoceros is quite interesting, but it really depends on what you want to do. You have SolidWorks for texturing, what I named before, ZBrush. So there's all these CAD softwares that you can choose from. I would say is you can mostly have a trial period of like 3 months or something like that. Check it out first. Look at some of the videos, tutorials, like, okay, this is my thing, or this is maybe not so my thing. Then like look at a lot of the materials, so you can really utilize those 3-month like trial period really well. Once you start a 3-month trial period, try to do a little project every day, or go on with something, even if it's half an hour. Try to do it every day. Maybe try to do a different tutorial every day or something, so you can really like learn it, and you can really see after those 3 months, like, is this something for me? Do I want to buy into this, and all of that stuff. A lot of what you see happening is that people get into that they do the trial of 3 months, and then they use it every week 1 time, and then the trial is already gone. So really have your strategy on that, because otherwise you're gonna pay and not experiment and just pay for the real thing, and it might not be your thing, right? So but Onshape is one of the ways that you maybe want to explore with this. I created this project called the Screen Dress. It's a project with these sort of eyes. They're hyperpixel screens, the Hyperpixel 2.0 screen from Pimeroni. So you can, use things to them. They're touch, you want to play games with them, or you can also program something for that. In this case, they're speaking to Raspberry Pis that are on the back. So each of these eyes, you can see 6 eyes has a Raspberry Pi on the back that is doing all the interaction. And what is happening is she has a BCI, 4 sensor BCI that's doing measurement in the back of the. There's 4 sensors there that are doing BCI measurements, or by computer. It's a brain and computer interface, and it does measure the brain waves. It measures the workload. So when the wearer is getting more stressed, the pupils will react to that, and the pupils will get more wider the more stress there is, and less wide when there's less stress, sort of, you know. So that's kind of a really fun showcase of the data. The other thing which is kind of interesting from more the mathematical side, sort of, is that your pupils will never fully close, so they will never be 0, and they will never fully widen, so they can never be 100. Yet also your workload and your brain signals can never be 0 because you would be dead, or they can never be kind of 100 because you would also be kind of, that would be really, really wild and sort of. So there's this boundary between the 20% and the 80%, and in that boundary, all this data is correlating to each other. So it can be 20% of the, kind of the going towards lower. It makes the pupils go smaller and wider. In that, in sort of. So here's the unicorn band, which you can see here. So it has active dry electrodes. So it sticks to your hair and the back of the design, and it's non-invasive. And here you can see a little bit how the setup is. So you can see the screen rest, the 4-channel ED headbands. So the unicorn goes over Bluetooth to the computer, measures the engagement score. So this is where we're measuring the brain signals. Goes over Wi-Fi to the hyperpixel. So that's the Raspberry Pi. I'm using Raspberry Pi Zero W's, but the second version, because the first version had a little bit of latency of sending these the screen sender to the screen, sort of, and goes back to the screen rest. So this is a little bit how you can see that go. So again, in the beginning we talked about the input and the output. The input in this case is again the EEG headband. In case it's a computer, it's not a Raspberry Pi, it's not an Arduino or something, it's a physical computer that is doing all the kind of the measuring and collecting the data and all of that stuff, and is sending it to the hyperpixel, which kind of collaborate together to the screen rest, and the screens are kind of the outputs. So in this case, there's a computer in between, and then also the 6 Raspberry Pis that it's pushing the data through in order to create this interaction. So here you can see a little bit about the engagement and the rest. So when the pupil is the smallest, middle, and the biggest, and also the validation of engagement and the rest periods, for example. And with this one, we did a lot of like kind of tests, and we also have it as a white paper online if you want to search for it for more of the research behind this as well. But for me, it's a really fun project where you can see directly the correlation between the data, the input, and the output as well. You can see, think of a QDoc. You can see somebody, and I'm asking this person, like, think of a QDoc, and you can see the system react to that, sort of. So, this is, I think, the project that I'm gonna present. Oh, one thing is with the use of BCI. So if your heartbeat, do heartbeat sensing or any other sensing, you can place it on the body. It just needs a little time to verify and validate. It might need to calculate your baseline in order to have certain validation tests. But if you're working with BCI, so basically interfaces and brain signals, you always need to go through some kind of test, little testing settings. Okay, so this lesson is like 150 minutes that somebody needs to do it well. Basically, we need to recalculate and validate the baseline, so then also like look at the brain signals. So a lot of the designs that I do have been, the things that I've been showing are more sculptural, like on the body. You can also think of like printing on the fabric itself. One cool way is the from Stratasys, the company Stratasys. You can think of the textile 50s, and you can 3D print on fabrics. I have it here, but I'm currently doing a few projects with students with that machine. It's a really cool machine. It's basically their old Object Connect 500, I think, that they rebuilt into printing fabrics and textiles. So that's pretty cool. But you can also 3D print with other things like elastomer. You can also use your Elegoo printers in order to do tests to print directly on fabrics. And again, I would personally use the TPU or like a TPE, like development of Elegoo if you're doing so. But you can think of like 3D printing and also automatically like integrating technology like LED technology. In this case, for example, what I'm doing here. This was not with Elegoo. This was with the company Chromatic 3D. In where we were 3D printing with elastomer on fabrics. But again, like such tests you can also do, and I would love to see that if you're like need to have an application in where you still need soft goods like fabrics, in where you can directly 3D print on fabric sort of. So yeah, that's something that a lot of the community is also doing. And there's also a lot of things online to be found around that. What I mentioned before, yeah, prototyping, I already told you about the mockups, the prototypes. My designs also have like versions. So sometimes I have a version 1.0, version 2.0, version 3.0. And the more I learn or I see a newer technology, I'm like, oh, I want to remake this dress, and it's the version 1, 2, or 3. So my first version of the spider dress was this one. It was like laser cut. I was in a hackerspace with Daniel Schatzenmeier, is a friend of mine. And we were playing around with spider bots and all of that stuff. And that really inspired me to create, yeah, this dress sort of. And yeah, that was laser cut from 3mm plexiglass, and it has a lot of screws in there. So that was one of the reasons that I later on wanted to like 3D print this design to have less screws. But the cool thing was that it was a little bit lighter sort of, so the mechanics and sort of the inverse kinematics and all of that stuff, like it reacted a little bit more light. So the third version of the spider dress that I want to make is definitely like kind of a lighter one, so I can better animate it, because some of the servo points are a little bit yeah, too heavy currently. Here you can see some of the animations. This is the Yukon steel, and it did some like animative movements as well. And also the smoke dress had a few versions actually before. One was with dry ice, one was with me hooking up a really big smoke machine to basically the version that I have now. So I think the version that you saw was already the 6th version, the one that I worked on with Nicolo. So there were like a lot of versions in between. And this was, I think, the 3rd one. In where the piece is not 3D printed, but I created it with yeah, sewing and disappearing fabric, and then like tracing it with nail polish actually. So this piece is basically just thread and nail polish. So yeah, there's of course a lot of ways that you can do shaping of things. But that was the baby yeah, dress. In terms of workshops, I do a lot. What I mentioned before, I do a lot of educating. So I'm either educating master students, so that's mostly from technical universities or yeah, different universities or schools. But I also work a lot with children doing workshops and all of that stuff. And one fun workshop that we did with a teacher in Austria, Michael Brandl, he was with his students, he was rebuilding some of the designs. So this was the spider dress, and they rebuilt it from Lego Mindstorms. And I thought it was really, really cool what they're doing, because yeah, one thing is like 3D printing it, but you have all the, except for the limitations of the technology, you have a lot of ways to go. But rebuilding the spider dress is one thing, but rebuilding it from Lego Mindstorms is totally something, yeah, that blowed my mind sort of. So these students were rebuilding some of the systems in Lego Mindstorms. The Lego community is really, really cool always, but I think just the level of detail, and the system was also really working. So yeah, again, like designing something is one thing, but rebuilding a design from a really hard medium like Lego Mindstorms is totally a different thing. And they also started to do that with the Lego, the cocktail dress. You can see that here, and they actually showcase that again at Roblox.k, where I first launched the cocktail dress in 2008 with James Marie Skintle, that I was doing an artist in residency with. So that was really, really fun and actually really working. So I just wanted to give them a shout out that that's also really fun. Lately, I've been seeing a lot of people that were like kind of 3D printing their Lego blocks to make them very modular. So that's also a really fun thing of you to think of when you're working with your Elegoo machines, to create things that you can click together, like almost like Legos, right? Inspired by that. So one of the projects, and that's not necessarily, but it's very modular as well. If you're working with like smaller printing pieces, you might want to merge together. This was again with Lego Mindstorms. What I did was making these mechanic wings. So you can see them online here. So they were both flapping, but they were also moving. So you can also use a lot of other things when you're busy with mechanics. You might want to use inspiration from other mediums as well. So the last part, and I know I'm 1.5 hours in now, is open source. Open source is really, really important into, yeah, I think designing and creating. Like as we create, we learn from other people because we're like, yeah, we're Googling how things need to be done, or we're seeing like people post videos on like, hey, this is how you do that. I think it's really important for any creator, whether you're an engineer or an artist or a musician or whatever, or a coder, to kind of work with open source. And also as a company, companies are often afraid of open sourcing because they say like, yeah, we don't want to be known as we're open sourcing our ideas in our company, so they're really wary of it. But it's not about that necessarily. It's about like a little thing that you might not use yourself that you can possibly open source, and you can also tap into the community with that sort of, because community is just really important. So the ways that you can open source is making and sharing with your community. If you have code, for example, you're writing code, you can put it on GitHub, for example, you can open source it there. Make and Maker Faire are big supporters of anything open source as well. Thingiverse, if you have 3D models that you want to put online, maybe you created a ring, and you're like, okay, that's cool, I learned from that, but it's just sitting on your desktop. Like maybe you want to upload it on Thingiverse and somebody gets married or has a fun party with it, or uses it to give it to a friend or something like that, you know. So what do you have on your desktop that you learned from and that you're like, okay, but it's just sitting there? What can you upload back online to make somebody else's life maybe happier or something like that, you know? I think that's mostly how you can see it. Otherwise, it's just like lost on your desktop and you might never look at it anymore. So how can somebody else use it? Instructables is from how to make tomato soup to how to make your own robotic dress, basically. You can find a lot of projects on there. Definitely look up this, for example, the 3D printing on textiles on both Instructables as also Thingiverse. I think you might be able to learn from that, and then you can start to design your own thing. Like, okay, I use that, I learned from that, and how can I how that more? Then Hackster.io is if you want to get more into like hardware related things, more hardcore hardware related things. There are some like 3D printing projects, but I would not, you would more find hardware. But if you want to get into hardware, that's really the place to be, sort of. And then the other thing is OpenBCI. So the OpenBCI brain computer interface community, mainly around San Francisco, is really interesting if you want to get more into brain signals. Definitely dive into there. So yeah, some of the projects that I have been creating, and I definitely need to put more on there, is they are on Instructables. So for example, my how to make your own robotic cocktail dresses on there, and we're going to go through that in the last 20 minutes that I will still have. Also how to make these badass mechatronic Lego Mindstorm rings, the teardown, the Mindwave teardown that I already showed you. I did an open source element dress that people could like 3D print their own parts and send them to me, and we made this whole dress out of it. We did it in a few maker fairs. Long time ago, people were interested in what kind of microcontrollers you use for your electronic fashion, but that's really outdated. That's really from 20 years ago. But then also how to get fashionably struck by lightning, which is creating your own Faraday dress and standing in between 2 times 500,000 volts of electricity, which I would not recommend making it, but it's fun to see how it got made. This is, for example, my Hackster.io tutorial that I want to point you at. It was about making light up kitty ears, so you can 3D print the physical piece, and then you can create your own PCBs, or the Gerber files are there. You can send them out, or you can just customly make their own. Here you can see a little bit on how how things when I'm making a tutorial. So you can see here like all the parts and like all the steps. So you really want to document it well. So you really want to like showcase all the sort of the stories in there, how to print them, how to redesign them using Fusion in that case. Getting the circuit board, you can mill them out, you can print them, be creative, create your own. You can make them using Lilliput, Arduino kind of components as well if you're if that's into using sort of more certain fabric materials. Here you can see the PCBs and basically step by step on how to put all the components in those parts, which you can see here a little bit. And then also like how it looks in the end. So I try to do it pretty thorough. I try to let it read through a few people before I put it online, because otherwise there's a lot of confusion. And of course, also if there's still things unknown, people will post it like, hey, how did you do this or this? And then I try to adjust it again. But yeah, as you're creating your projects and you want to document it for a site like Instructables or Hackster.io, make sure that always when you're doing a thing, be like, okay, is this interesting for my process? Make a photo, or always have your camera on, for example, focused on whatever you're doing, then you can cut it out in order for you to really visualize how you do these things, for example. And then, what I do with it is a lot of like, workshops and all of that stuff. And I test it out also through these workshops before, for example, I put it online on things like Instructables. So yeah, in regards to open source, it's really make cool stuff, learn from it, and then also open source to share it with, basically the world around you. So that's a little bit the end of my talk. So if you have anything, fabrics in there, if you have anything around the body or anything else, maybe you're making a robot and you still want to have advice from me, definitely join, because I would love to see all of your, be able to feedback it. So it doesn't necessarily have to have technology in there. This workshop was more to inspire you guys to maybe work with electronics and technology, or see electronics and technology in in a way. So yeah, sign up for your project, even if it's not technically enhanced or even have to do with the body. I'm just happy to help you guys and to see also what you guys are